Hey guys, welcome to the second part of my presentation. Here we're going to see how Kafka and Storm um, work together to solve real-time problem. So let me define the problem first. So let's assume that I have information coming from all over the world, what people are trying to buy and sell from the exchanges. For example, people would try to buy Microsoft, or they're trying to sell Google, or somebody's trying to short Facebook. So we have all this information coming from all over the world, um, and um, and the result that I'm trying to get out of all this information is that on a day, how many times people are trying to buy IBM or sell Microsoft, for example. So I have a list of predefined symbols here. IBM, FB stands for Facebook, Apple, Microsoft, General Electric, General Motors, and I have a list of predefined actions: buy, sell, short, and cover. And these are the exchanges: NASDAQ, NYSE, and I have also compute a random amount, but we don't care about the amount and exchange, which we're gonna parse and filter out in our spouts, in our bolts, and then we're gonna make use of this action and the symbol, and we'll process this information in the database, and this is real time. So as soon as you have this information published to Kafka brokers, our Storm spout is gonna get this information and give it to all the bolts that are available, and the bolts are gonna process this data and update our database. And as soon as you query your database, you have the information ready. And you could probably publish this information through your website, or you can have a web server, give the information to the outside world so that they can display it. So there's a lot of things that you can do with this information. So and obviously I'm using a simulator here. I have predefined symbols, predefined actions and exchanges, and I also compute random amount. And this is my Kafka producer, and as you can see, my topic is trade frequencies. This is what my trade spout would query from the brokers. I basically get a next trade, which is basically going to create this message, and I also compute this random IP addresses, so that it would look like it's coming from different parts of the world. And I'm just printing it out to the console as well as sending it to the brokers. And let's look at the trade spout, which makes use of Kafka consumer spout. As we have seen in the previous presentation, that the framework would call the next tuple. We make use of this method and give the framework the next values, right? So we get the next value from Kafka spout, and if you look at Kafka consumer spout, which is basically making use of Zookeeper, and also it has this unique group ID. As we have seen in the previous presentation, consumer to consume messages from broker, it needs to have a unique group ID, and this is a consumer group ID that my consumer is gonna use to read from brokers, and that's pretty much it's doing. If you look at the consumer test, this stream iterator is to read from the Kafka brokers, and it just gives the next message. And let's look at how the topology is built. So this is my Storm topology class, and I basically say, hey, builder.set spout. This is my trade spout, which is going to talk to Kafka consumer spout and read the information from Kafka brokers. And I say, give that information to the bolt, which is the action symbols bolt. Here we basically remove the exchange and the amount information, which we don't care, and pass that information to the buy sell count. and the important thing to note here is that the first bolt does not care about the messages. So in message, the way in which it's grouped, so it says I'm okay with the shuffle grouping. So the framework just randomly assigns to any bolt here. But the next one makes use of field grouping because we need the same symbol and same um, action to go to one bolt, so that we can have the right count for that action and for that symbol. Okay, and this is running in the local cluster. So Storm is in the local cluster mode, and I submit my topology, and that's it. So let's have a demo of this. Okay, let's do the demo. As you have seen in the previous presentation, both Kafka and Storm make use of Zookeeper. So we first need to start Zookeeper, and I'm gonna do that now. Looks like it is successfully started, and I'm gonna start my first broker, first Kafka broker, and I'm gonna start my second Kafka broker, and I'm gonna start my third Kafka broker. Okay, now I have my Kafka cluster ready. Now my producer can start to publish messages, which I'm gonna do now. Before, okay, let me copy this. Okay, Cassandra is running good. Let me see. Yep, it's running. Let me go into SQL shell, and let me see if I have anything in the database. Yes, I have run this program multiple times. So I have, you can see Apple, buy, cover, sell, short, GE, IBM, GM, Microsoft, trade frequency. These are the times these trades have been ordered by people. And now it's time to start my my producer. Paste it, and you can see it's publishing messages, sell, GE, some random number, then it's the exchange that needs to buy or sell. Okay, now I'm ready to start my Storm topology. Okay, now you can see Storm is processing all the messages, and I have a trade count query. This is basically reading from my database, and you can see my Storm components updating the database based on what they are seeing. You can see Apple going up. You can see all these numbers updating. So we are basically reading from the Kafka brokers, giving it to Storm components. So the first the spout is giving the information to the bolt. The first bolt filters the unwanted information, calculate the count, and update the database. So this is going to run for some time, as there are many messages in the broker. We have asked it to shut down after some time, so now Storm has stopped processing, and that's it. These are the latest information, and you can publish this in your website, or you can sell this information. That's it. Now you've seen how Storm and Kafka work together to solve a simulated real-time problem. Thanks, guys.